Hello and welcome back. So continuing on with our Lexer, in this video, Nelson is going to be doing implementation. Nelson?
Alrighty, so the first step of implementation is just filling out that base class that we have right here. I'm going to go ahead and hide out our unit tests because I hope that none of them pass by the end of this or the end of this portion of the video. So we're going to start off with initializing our stuff in the constructor, which is basically just going to be setting the input to input, and then also setting the initial value of character. Now, character is going to point to the current character within the input that is represented by our pointer member. So what I'm going to set character to initially is going to be input.length is greater than 0. Let's give it out our input at pointer. Otherwise, just a null terminator character. And so now we have a good starting place for our character. Now the rest of the methods these are just going to be helper methods. The goal of this part of the Lexer is just to be able to match characters as they come in through the input. So the first method is going to actually be called match. It's going to be protect void match character to match. And the implementation of this method is straightforward. If toMatch equals our character, then consume. Otherwise, throw a new invalid operation exception saying cannot match char that char found that expected that. And we found character and we expected to match. And then just because I'm working in a very low resolution, I'm going to go ahead and break this out a little bit for readability. Now the consume method is going to be also very straightforward. All the consume method is going to do is it's going to increment our pointer. It's going to check to see if we are at the end of the stream. So we're going to write another method called isEOS. If it is, we're going to set our character to the null terminator and just return out. Otherwise, we're going to say character equals input at pointer. So I guess another method that we can go ahead and implement now is isEOS, which is very simple. Public bool isEOS will simply return pointer, or pointer is greater or equal to our input's length. So if we're at the end of the stream, we're done. Finally, I'm going to go ahead and implement a few helper methods. Now these helper methods are going to be very simple, but they're going to make our code a lot more readable. The first one I'm going to do is protected bool null is letter, which will return character.isLetter for our currently selected character. Then we're also going to do isDigit and isWhitespace. So isDigit, which is going to return isDigit, and isWhitespace, which is going to return isWhitespace. So we're just delegating off to that to make our parser or Lexer code a little bit more straightforward. Finally, I'm going to create a helper method for instantiating tokens called createToken. That gets a token type, a start, and an end. And we're going to return a new token given the type and the start and the end, and of course the input. So that's our base class. It's just lets us write some really relatively clean code in whoever inherits from it. So now moving on to the actual Lexer, the CGS Lexer class, we can now implement our next token class using all the functionality we just implemented in our base class. The first thing I want to go ahead and match are identifiers. Identifiers are relatively easy to match. We see that if the current character that we're on starts with a dash, an underscore, or a letter, we know that we're looking at an identifier, and we can just treat it like an identifier until we hit a whitespace character or a no, that's really about it, until we hit a whitespace character or the end of the stream. So the next token method is basically going to be a while loop. While we're not in the end of stream. Next thing we're going to do is say, if we're in whitespace, then we're going to parse whitespace and continue. The parse whitespace method basically will just simply consume our code or our stream until we hit the end of the white space. I just broke it down to it's a relatively simple method. I broke it out because the indentation started getting a little crazy. So I'm going to say while is white space consume. So basically, every iteration of this loop, when we ask for next token, it will make sure that if we're on a white space, we will be out of that white space by the time we start the first real iteration of this loop. And the first real iteration is going to be simple for now. We're going to say if predict identifier return parse identifier. So again, keeping the code as simple as possible, because this kind of code can get very convoluted very quickly, and you will have no hope of ever extending your Lexer after you've written it. So I've broken out a lot of things into different methods to make things more clear. The predict ident method will just return is letter, or character equals dash, or character equals underscore. If character equals any of these, we are in an identifier, and we can go ahead and safely parse that identifier out. So I'm going to go ahead and move parse identifier underneath all of those methods and give it an implementation. The implementation of parse identifier will be very simple. We're going to start out by saving our start position. Then we're going to say do consume while predict ident or is digit. It's a little funny syntax that I kind of stumbled upon when I was writing this method initially. I think it looks kind of cool. I mean, what do you think, Jason?
Yeah, it's all right.
Oh, it's all just all right. I thought that was neat. It looks like something out of a functional programming language. I mean, although it is an imperative construct, it just looked funny. I don't know. It was cool. I had fun. So then I'm going to return a create token with the type ident, the start of start, and the end of pointer -1, because if we exit this loop, that means we are now we're now pointing to something that isn't an identifier and isn't a digit. Of course, I'm also going to, just so we don't get into any nasty infinite loops, I'm going to also add in, and we're not at the end of stream. So that's our identifier code. Resharper is still being stupid for some reason, so I don't know. Then we're going to, in the case of next token being, or exiting this while loop, without matching anything that it needs to match, we can assume that we're at the end of the stream. So I'm going to go ahead and say return create token, end of stream, starting at pointer and ending at pointer, because we don't really care where it starts or ends. Okay, let's close this file and open it back up, and Resharper still is being stupid. Whatever. Let's go ahead and run our test and see what happens. We get an infinite loop, which is what I didn't want to happen. So we're going to go ahead and figure that out, why we are getting an infinite loop. I'm going to assume that we're getting to a parse identifier. There isn't any reason why we shouldn't be getting to parse identifier. And I'm going to launch debug mode. This is another thing about Lexers and parsers. If your code isn't very clean and concise, debugging is a pain, and you will inevitably have to debug it. You know what my problem is?
What is it?
Given that nothing was matched, it didn't consume. So it sat there on a non-EOS character. It didn't predict a white space, and it didn't predict an identifier. So let's go figure out why that is. Let's look at our character. Character is a dot. What? Oh, you know what? I'm running the wrong test because I'm stupid. We're doing this test. Ignore the other tests. Ooh, look, success.
Hey.
See, I was actually totally right at the beginning, but then because I ran the wrong test, I second-guessed myself. So yes, this test now passes. We can now successfully parse identifiers. So let's move on to numbers. Numbers are a little bit more complicated. Let's jump back over to our CGS Lexer, and we're going to follow the same pattern here. We're going to say if predict number return parse number. And our predict number is going to be very, very straightforward. It's going to be if we are currently on a digit, or our character is currently a period, which is acceptable because it could be .5, for example. And then we're going to say parse number. And I'm going to go ahead and, just like I did before, I'm going to move parse number below, underneath parse identifier. So like I said, this is going to be a little bit more complex. It's going to be kind of a little imperative little method that's going to have to identify a few different kinds of cases. Just like with identifier, we're going to start by caching our current pointer. Then we're going to declare a variable called found dot. I'm going to set to false. Then we're going to say do if character equals dot, then if found dot, then found dot equals true. Otherwise, we are in an invalid number. So we're going to say throw new invalid operation exception, invalid number. Finally, at the end of this, we want to make sure that we advance our pointer again a little bit. So we're going to say consume. Then we're going to say while we're currently sitting on a digit or a dot, which we can just reuse our predict number method for, and is not the end of the string. Finally, we're going to return create token of type number, start, and pointer -1. Okay, let's go ahead and run our returns ident and returns numbers, and hey, we got success on both these tests. So now the next step is parsing strings. Strings are another complex thing, a little bit more complex than numbers. So we're going to start with basic pattern again. If predict string, then parse string. If predict string, then parse string. Predict string is going to be very simple. We're going to say return character equals single quote, or character equals double quote. Parse string method is where some interesting stuff is going to take place. I'm going to go ahead and move this all the way to the bottom so we have a nice little consistent format in our member ordering. And then we're going to start parsing strings. And the first thing we're going to do, like always, or not always just yet, is we kind of want to eat our first quote. We don't care about the first quote because, as far as CSS or CGS is concerned, single quote strings are completely identical to double quote strings. And once we lex a string token out of the system, we no longer need to keep track of the quotes. So I'm going to say var single equals character equals single. This Boolean will say if we're in single quote mode or double quote mode. So I'm actually going to rename it to in single quote string. Then we're going to consume, so we're going to skip over that thing, and then we're going to record our start position. So position equals pointer, and then we're going to get into some fun stuff. We're going to say while in single quote string, and character does not equal a single quote, or if we're not in a single quote string, and character does not equal a double quote, then do stuff. The first thing we're going to do is we're going to identify invalid strings. And an invalid string can either be a string that does not terminate before reaching the end of the stream, or does not terminate before reaching a new line or a character feed. So I'm going to say if is end of stream, or character equals new line, or character equals line feed, then throw a new invalid operation exception called unterminated string literal, which is common verbiage for these sorts of situations. Then I'm going to say consume. Finally, if we reach the end of this while loop, our pointer is going to be sitting directly on either a single quote or a double quote. So we want to shove that out of the way by consuming it. And then we want to return create token with the token type of string. The token type of string, a start of start, and an end of pointer -2 because we want to eat up that stupid quote. So at this point we have our string stuff. Let's go ahead and see if this passes.
All right.
Oh, look at that. So now we can parse all these awesome strings. So now the final thing we have to do is we have to actually parse a lot more stuff. But the funny thing is our parse or Lexer isn't actually going to get a lot more complicated because the only thing we need to actually parse are single character tokens. You see, out of all this stuff, the only thing we're missing is things like semis and curlies and stuff like that. And then we're also missing PX and PT as well, which we'll need to figure out at some point. So I'm going to start off with the single character tokens, which are very simple, because all we really need is a handy little dictionary of type char and token type. We're going to call these basic tokens. Then we're going to initialize this dictionary with all of the basic tokens that we support, such as colon and so on. And this needs to be single quotes. And I'm going to go ahead and copy and paste this a million times because I don't want to type it out. Then we're going to start with semis, operands, close parens, dots, hashes, greater thans, commas, modulus, open paren, close paren, and am I missing anything? I could have sworn I added something else to token types. I don't know how I got there. Token types. Do we need... Yes, we're also doing pluses. So now let's actually fill out the right side, because obviously that's not valid as it is. We're going to start it with plus, semi, O paren, C paren, dot, hash, greater, comma, percent, O paren and C paren. I messed up those earlier, actually, because these should be O curly and C curly. So those are all the basic token types that we support. And parsing them is, we can parse them all in just one basic step. We can say token type basic match, and we can say if basic tokens dot try get value with character out of basic match, then if basic match is a dot, now this is the interesting part, and something that we haven't actually implemented yet. We want to know if the next character is a number, because if the immediate next character is a number, that means we're actually working with a decimal or a decimal point instead of an actual dot. So we need to actually implement a method that will allow us to look ahead one character into the future. We're going to do this on our Lexer class, and I'm going to go ahead and stick it above consume. And I'm going to say protected char look ahead. I would say return pointer is smaller than input.length. Input pointer +1, otherwise null string. So this will just go ahead and give us the next character in the stream, or a null string if, or a null character if we have already eaten up all the input. So then I'm going to say char is digit look ahead. Then actually what's going to happen is a little bit different. We're going to just return out a parse number. Then finally we're going to match our character, which this should never fail, but whatever. And then we're going to return a create token of type basic match, pointer -1 and pointer -1. Start and end is on the same character. So let's go ahead and see what this gives us now. Sweet. So we got all the way up to the thing that we haven't actually implemented yet. And how we're going to implement PT is interesting, because PT will already parse as an identifier, which we can use to our advantage. On our parse ident, we can go ahead and, our parse identifier method, we can go ahead and say var ident token equals, And then we can say if ident token equals pt, using our string comparison dot invariant culture and ignore case because it's case insensitive, then you're going to complain because I should do ident token dot text equals. If it equals pt, then we're actually going to return a new token. We're return create token pt with start and pointer -1. Otherwise, we're going to say if it equals px, we're going to return px. And then we're going to go ahead and return ident token if none of that is true. And then finally, we're going to also support, never mind, we'll do that later. So this is how you would actually generally parse out keywords of your language. You would first identify an identifier, and then you would match it against a dictionary of known keywords. And then instead of creating a token of identifier, you'd create a token of individual keywords. So let's go ahead and run this and see what happens. Boom.
Nice.
So basically, that's really awesome, and I'm amazing.
That was worth the video just for that, Nelson.
So now you see we're correctly lexing this text right here.
Yep.
And the CGS Lexer is not intimidating at all. I mean, I did work really hard to keep things as straightforward as possible. You can make Lexers that are very convoluted, but that really makes them impossible to extend or to debug when you find problems. Mm-hmm. You'll also notice that I have a very brute force error handling situation or recovery mode, in that it just throws an exception and dies. But I'm not going to worry about dealing with error handling. Basically, the theory behind error handling is that you ignore the character that threw the error, and then you try it at the closest. You look at the next token and you find the closest match for whatever possible token that might match. And we're not going to worry about dealing with that because that's a lot of extra code. Also, Antler does that for you all automatically. So currently, if you pass an invalid code, it's just going to die. Mm-hmm. But yeah, so that's our token, or that's our Lexer.
Awesome. So that's going to wrap up the Lexer, and from here we're going to move into the parser.
Yep.
All right, guys, we will catch you in the next video. Thanks a lot.